Hi all, welcome to my All for Science channel, and here is this week's version of latest science news. The first news is about chikungunya infection, whose antibodies have been developed by ILS, the Institute of Life Sciences, as reported by The Hindu on June 23, 2019. Chikungunya, as most of us know, is a viral disease that spreads via infected mosquitoes, and symptoms may include headache, fever, muscle pain, joint swelling, or rashes. The work has been in progress at the ILS laboratory for almost a decade, led by Dr. Soma Chattopadhyay, a senior molecular virologist. Previously, there were no antibodies reported against chikungunya viral infection. ILS states that Dr. Chattopadhyay's group has been the first to develop and characterize novel, highly sensitive, and specific polyclonal antibodies against the non-structural proteins NSP1, NSP3 and NSP4 of ChIKV, and also a monoclonal antibody against NSP2 of ChIKV. Dr. Chattopadhyay has explained that these particular ChIKV proteins were chosen as targets because they play a critical role in virus survival by governing the overall process of replication and infection in host cells. Development of these antibodies, that is NSP2 monoclonal, NSP1, NSP3 and NSP4 polyclonals, was therefore crucial to perform experiments pertaining to ChIKV infection. Number 2. The tenure track system draws divergent opinions from researchers in India. Ministry of Human Resource Development has called for a meeting of all 7 directors of the Indian Institute of Science, Education and Research to discuss the pros and cons of the tenure track system. The tenure track system is a system where the performance of a young faculty member joining as an assistant professor is evaluated at the end of 5 years, and his position is made permanent if his or her performance has been satisfactory. If the person fails to make the cut, he or she is asked to leave. Some institutions, such as Tata Institute of Fundamental Research and the National Centre for Biological Sciences, Bengaluru, already have this system in place. In the United States, this is a prevalent system. However, this has rattled the scientific and research community in India. Let's see the points raised by the two camps, one in favor of introduction of the tenure track system and one against it. Those who support the move say that this will improve the quality of research done in India by leaps and bounds, since the researchers will be held accountable if they cannot produce quality work. Those who are against it also have some valid arguments, and they say that this will foster insecurity amongst the researchers and negatively affect their personal lives as well as academic performance. Young scientists and researchers under this system would be forced to focus on short-term, achievable goals of not much societal importance and neglect long-term research work that can cause real significant changes in society. Also, the system is said to be unfair to young scientists, since it would make the young faculty members vulnerable to the administration and the seniors. A fair system would place the same, if not more, onus of accountability on the senior professors, deans and directors. All of us Indians want research in academic institutions to improve, so there needs to be more debate about the tenure track system before taking a decision to implement it, so that the wider scientific community reaches a general consensus regarding it. Number 3. Clues to the origin of life found in cyanide compounds in meteorites. A team of scientists at NASA and Boise State University have discovered compounds containing iron, cyanide and carbon monoxide in carbon-rich meteorites. These meteorites containing cyanide belong to a group of carbon-rich meteorites called CM chondrites. It's not uncommon to find cyanide in meteorites, but what's uncommon is finding cyanide along with carbon monoxide bound with iron to form stable compounds in the meteorites. They identified 2 different iron cyanocarbonyl complexes in the meteorites using high-resolution liquid chromatography mass spectrometry. These iron cyanocarbonyl complexes resemble portions of the active sites of hydrogenases, which have a very distinct structure. Hydrogenases are enzymes that provide energy to bacteria and archaea by breaking down hydrogen gas. They are large proteins, but like most enzymes, they have an active site, which is the region where chemical reactions take place. This active site happens to be a much smaller metal organic compound contained within the protein. It is this metal organic compound that resembles the cyanide-bearing compounds that the team discovered in meteorites. The similarities between the active sites in hydrogenous enzymes and the cyanide compounds that the team found in meteorites gives us some clue as to how biology could have arisen from non-biological chemical processes billions of years ago on Earth. It is funny because cyanide and carbon monoxide on their own are poisonous to humans, but these very compounds may have been vital in making molecules which are useful to emerging life. Number 4. The mystery of Mars methane continues. NASA's Curiosity rover has detected high levels of Martian methane while testing the air of Gale crater, and the amount is some 21 parts per billion. Scientists don't know for sure where the gas is coming from or what is producing it. Methane can be a byproduct of microbial life, but it can also be produced through geological reactions or created in the atmosphere from carbon in solar system dust. To add further to the mystery, a few days later when the experiment was repeated at the same spot by the rover, the methane was almost gone and had fallen to its normal level in the Martian air, less than 1 part per billion. Scientists are now looking forward to analyze the data collected by 2 Mars orbiters, European Space Agency's Trace Gas Orbiter and Mars Express, to check if they had managed to catch a trace of the big burp of methane that Curiosity had captured. For now, it is safe to say that the Martian methane mystery continues. Number 5. 75 by 75, India's 75th birthday plan. India will turn 75 in 2022 and could celebrate its 75th birthday by sending 75 tiny satellites built by students of Indian universities into orbit around Earth between late next year and 2022 in batches. 75 by 75 is the dream project conceived by the Indian Technology Congress Association to celebrate the nation's 75th birthday. Students of participating institutions would come from different disciplines and get to build nanosatellites weighing between 3 and 12 kg. They will have to showcase a novel concept, science experiment or technology in orbit. In the last 3 to 5 years, other countries launched about 3,500 student satellites that demonstrated innovative technologies, but Indian universities have so far built and launched only 9 satellites. Space-based solutions can be far-reaching in its impact and help people in remote areas where many other technologies do not reach or work. Students can learn to design small satellites that can offer simple, meaningful, and low-cost solutions to soldiers, farmers, fishermen, forest personnel, or students. 6. NASA's billion-dollar drone to Titan. NASA announced on June 27 its billion-dollar mission to send a drone-like rotorcraft to Saturn's largest moon, Titan. The innovative quadcopter has been fancifully called the Dragonfly. This will be the 4th mission in NASA's New Frontier series, which previously launched the New Horizons to Pluto, Juno to Jupiter, and OSIRIS-REx missions to the asteroid Bennu. After its launch in 2026, it will travel in space for 8 years before finally landing on Titan's equatorial desert in 2034. There, it will search for impact craters or ice volcanoes, energetic processes that could provide a spark, and the liquid water needed for nascent organic chemistry. Over the course of its 3 years primary mission, it will travel 175 kilometers and fly to dozens of different locations. It will use instruments like spectrometers to identify the terrain's chemical composition and a seismometer to sense vibrations. In the air, it will collect data about atmospheric conditions and take photographs of the alien landscape, which comprises hydrocarbon lakes, rivers, and seas. Titan is thought to harbor a liquid ocean beneath its frozen crust of water ice. Dragonfly's ultimate and primary target is the 80-kilometer wide Selk impact crater, where there is evidence of past liquid water and complex organic molecules. It will be a milestone for mankind if this mission finds direct evidence of life in Titan's hidden liquid ocean. 7. Drug used for Ebola treatment could counter Nipah virus. Researchers from the National Institutes of Health (US) have published a new study that shows that remdesivir was able to treat 4 African green monkeys which were given a lethal dose of Nipah virus Bangladesh strain. Remdesivir is a drug used for Ebola treatment and can stop Nipah virus from making new copies of its genome. The experiment included 8 monkeys inoculated with a lethal dose of Nipah virus Bangladesh strain, and after 24 hours, 4 of them were treated intravenously with remdesivir for 12 consecutive days. The ones that did not receive the drug succumbed to the virus, but the ones treated with the drug survived. Out of the 4 surviving monkeys, 1 exhibited inflammation of the brain tissues. Dr. Emmy DeWitt, the first author of the study, has confidence that the drug will be effective against Indian Nipah viruses as well, since the Indian Nipah virus belongs to the same genotype as the Nipah virus from Bangladesh that they used in the study. Dr. DeWitt has also confirmed that the drug is safe for clinical trial with humans. Number 8. AIST Kolkata predicts shape of the sun for upcoming solar eclipse. A team of researchers from the Indian Institute of Science, Education and Research, Kolkata, led by Dr. Dibyendu Nandi, has predicted how the sun would look like on the July 2 total solar eclipse that will be visible in parts of Chile and Argentina. According to their model, the sun will show 2 petal-like formations on either side of the corona with extended plume-like structures stretching out into the solar system from their tips. The sun's corona is the outermost part of the sun's atmosphere. The corona is usually hidden by the bright light of the sun's surface. This makes it difficult to see without using special instruments. However, the corona can be viewed during a total solar eclipse. The sun's magnetic field lines pierce through the corona. Coronal magnetic field gives rise to solar plasma wind and storms, including flares and coronal mass ejections. The magnetic field emerges from below the sun's surface and restructures the outer layers, changing the shape of the corona. The team has found a way to predict the shape of the corona well in advance. If it's successful, it will help us forecast how the sun's temperament can affect space weather. This in turn can help monitor the safety of electronic sensors in satellites, astronauts' well-being, and even the impact on Earth. Number 9. Indian scientist to be co-observer for NASA's Punch mission. Dr. Dipankar Banerjee, solar physicist from Indian Institute of Astrophysics, is the co-investigator of the Punch mission. Punch, which stands for Polarimeter to Unify the Corona and Heliosphere, is a NASA mission to image regions beyond the sun's outer corona in order to understand the transition of particles from the sun's outer corona to the solar wind that fills interplanetary space. Punch will consist of 4 microsats that will orbit the Earth in formation and study how the corona connects with the interplanetary medium. The mission is expected to be launched in 2022. India is planning to send up its own satellite Aditya L1 to study the sun's corona. And Professor Banerjee and his team will hope to use observations from both Punch and Aditya missions to understand better how coronal mass ejections affect space weather. This brings me to the end of this week's edition of Latest Science News. Thank you for watching. If you enjoyed this video and found it to be informative, hit the thumbs up and subscribe to my channel. So until next time, keep learning and keep spreading knowledge.